guys, I am Alferos from ECE31 and I am here to present my experiment number 1 about digital output. The objectives of our experiment is to learn how to create a project and build a project, to understand how the final code programmed to the microcontroller, and to create a simple code for controlling an LED. And for our equipment and components, we need our PIC16 F18875, this IC, a 220 ohms resistor, an LED, of course the breadboard, connecting wires, our PIC-IT, and our power supply. To give you a background to the digital output, this illustrates an example of digital output. So, digital outputs are binary outputs 0 or 1 from the PLC. It is a processed control output from the PLC to the field. It is used to on or off any piece of field equipment. Digital output is like a contact of a relay. When the pre-programmed conditions are satisfied, the contacts are closed. Digital output can be used to operate solenoid valves, relays, indicating lamps, or as a command to any other devices. That is for the background of digital output. In short, this is just a basic source and we are going to use a load like an LED. First things first is to have our MPLAB X IDE. We're going to go to File, a new project. Okay, let's wait for some second. There you go. Standalone project. And we are going to search our device with the PIC16 F18875. Click next, our compiler, and let's name this as experiment 1. Finished. So I am sorry guys for this type of recording since my laptop has a problem, and I think that this phone recording is much practical and better because there is a problem in my laptop due to it being slow, so pardon me to that. There. Next is that we are going to go to Tools, Embedded, and the MPLAB Code Configurator, and then we are going to select MCC Classic. Finish. So there, after some minutes, we are now here. So we have 3 peripherals. We're in interrupt module, pin module, and system module. In the GPIO, the 4th one, let's click this. There, it must appear color green and color something like orange here. And then after that, we're going to proceed with our pin module. So we are going to have a custom name for our LED, which is, let's say, LED underscore D2, and we are going to uncheck the analog, checking the output, and unchecking the WPU. Going next to system module, we are going to select our oscillator as high frequency internal oscillator. It's already there. HF internal clock at 4 MHz, it is already there. Clock divider 4, already there. And make sure that the low voltage programming is enabled. And after everything else, let us generate. So, generation complete. We are now going to proceed to our projects and look for our folder exp1. Under source files, we are going to select our main C file. Going down, we can notice there the while And based from our experiment, we are going to try to light up our LED on an on state for 250 milliseconds and off state for 250 milliseconds too. So it's like on off every 250 milliseconds. So let's code it. So let us type underscore delay underscore ms, and we wanted 250, and then enter. The name of our device, or the name we set a while ago, was LED underscore D2, right? Underscore, the default one is toggle, and then there, I forgot this one, there. And after doing this code, we are going to click this hammer-like button, build. Then we can notice that the build successful, total time 16 seconds. We are going to proceed with our MPLAB X IPE, the other one. But before that, we must first insert this, our cord, in our laptop or computer. There, you will notice 3 colors. So let me discuss first. This is called the lanyard loop, this one, wherein you can put something like a loop or lace. This one is the USB port connection, of course. This arrow here is called the pin 1 marker because there are 6 pins, so going here, from here, is that pin 1 to pin 6 respectively. And these 3 are the indicator LEDs, and this one, a button like here, is the push button, but mostly I just insert it and that's it. I already used my P3. We can use this, the one with the locker, wherein, because our goal is to connect our, this one, the PIC 16 F18875, but for me it is a hassle, this one, since I have to remove the IC from the board, then bring it back again after putting it here, then I'll bring it back again. Unlike if I already insert this over here, I'll just plug in the appropriate terminal to terminals, and then that's it. That will be good. So here, as you can notice, it is powered color green. It means power is applied. The active status is color blue. It means it is already connected in the port and the communication link is active. So the status, it has 3 colors, wherein if it is color green, it means it is ready to start, or the program is already successful. Orange, it is busy. And red, of course, it means error. So connecting this is that there is a notch in the IC. It means that's the right one. We have 40 pins, so from pin 1 to pin 40, this way. So the connection goes like, for the first one, it is the MCLR or VDD. We're going to connect here on the first terminal of the IC. And for the next one, second one, this is called the VDD, the 11th one. So let's count manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one. You must be careful because a wrong one will result may not to work. And for the VSS, 12.1, so the next to it, 12. There you go. And for the ICSP data, at the very last 40th slot, there, And for the IC SP clock, under that is the 39th slot over here, there. So from that, I have respectively connected from pin 1 to pin 5, into pin 1, pin 11, 12, 40, and 39. So welcome to our MPLab X IPE. As you can notice, our device was already recognized, the PIC16 F18875, and let's connect it. Let's just click OK. So there is a red mark. It says target device was not found. So in order to get rid of this, let's just go to settings, advanced mode. And on advanced mode, we are just going to type the default microchip password. So log in, and we are going to have additional options here. Clicking the power, the voltage level must be at 3.125. There you go. Checking the power target circuit from picket 3, and then we are going to operate. We need the file wherein it is called as a hex file, so let us just browse it, and our hex file, there you go. As we can notice, hex file loaded successfully, and all we need to do is to program. Okay, there, programming, and programming complete. And now we can take off our USB cord and proceed to the hardware. Since our hardware or the IC is programmed under the 6th slot or RA4, we just need to count 6. So from the beginning, 1, 2, 3, 4, 5, 6 there, and put the other end somewhere away. Let's say here. And we're going to insert our 220 ohms resistor there, and we are going to have our LED. Remember, the shorter one is the negative while the longer one is positive. And then we are going to locate our VDD and VSS, or the positive and negative respectively. So we all know that the VDD is at negative, 11 slots. So 6, 7, 8, 9, 10, 11 over here. And the other VDD on the other side is at 32nd slot. So 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. There. It says that we must connect both of them in the positive terminal. By the way, these two are the source, the 5-volt source. And also, under that VDD, so just under, so this is 11, so the 12 one is the VSS there. And if this is 32nd, the 31st is the VSS2, because on this IC we have a pair of VSS and VDD on both sides there. And then we have to do is to connect both of them on the negative side. Let's say here and here. So for the moment of truth, we are now going to insert our source on the socket. By the way, if you are asking, I have customized or improvised a power supply, DC power supply, wherein I used an old connecting wire, the charger one on the cell phones, because if you cut this, there will be 4 wires color red, color black, color white, and color green. So you need to omit or cut the color green and color white, and just let the color red and color black stay, as it will represent the positive and negative, while the white and green that is removed, that is the signal or data. And because buying a variable power supply, I have seen it really costs like thousands of peso. That is why from this we can improvise for a cheaper one if we need 5 volts, because this is a 5-volt one, as you can see on the label or specification. So let's try this. There you go, a fast blink, since we have toggled it on the command or on the program. And so in other words, on off for about 1 second. There will be 2 transitions of on off there. So let us take some time for it to appreciate. But for our next goal is that we need to have a delay of 2 seconds. So I'll just remove this. I have removed already. There. And going back to MPLAB X IDE, since our next goal is that we need a 2-second delay for on-off. We all know that 1 second is equivalent to 1000 milliseconds. So 250 will just be replaced to 2000. We are going to click build and do the same process. And after reprogramming, we will expect that this will have on-off toggle for 2 seconds interval. Let's do this. There. So as you can see, since it is now at a 2-second interval, it is much slower. 8 times slower this time. So let us take some time for it to be appreciated. Take this off, and for the questions, so it says that create the actual circuit as shown below to test the code, supply 5 volts in pin 11 and ground in pin 12. Observe what happened. So to recap, due to the toggle command with the time of 250 milliseconds, the LED turns on and off for 250 milliseconds too. And for the second one, modify the code in the main C such that the LED will blink at 2 seconds interval. Write your observation below. In order to achieve a 2 seconds interval, we just need to convert seconds to milliseconds. We all know that 1 second is equal to 1000 milliseconds. That is why we need to change the previous 250 milliseconds to 2000 milliseconds. This time, the LED turns on and off for 2000 milliseconds. And for the other applications, we have finally arrived at or concluded that this MPLAB code configuration or programming can be used on applications like when it's Christmas lights, of course. Since Christmas lights are composed of LEDs, series of LEDs, we can therefore use this type of device. And that's it, my experiment 1. I hope you have learned something. Thank you and God bless.